I am Ahmet, a PhD student in Linköping University. Today I will talk about backscatter communication. We can collect data from farms or we can track items in a factory using backscatter communication and low-cost hardware. Backscatter device is basically a sensor and our information source in this system model. And it doesn't have any active RF front end. It just reflects signal coming from carrier emitter to transmit its information to the reader. And it encodes the data by changing its antenna impedance. But the transmitted signal from carrier emitter also directly goes to the reader as an interference. And this interference may be 10 to 70 dB stronger than our weak information carrying signal. And because of this difference, the hardware in the reader can be saturated and we cannot detect information from backscatter device. It is like trying to hear whispers next to a jet engine. Earlier studies addressed this problem in digital domain in the reader, but by then the damage is already done. Instead, we reshape the transmitted signal and avoid blinding the reader. Our proposed solutions are for generic system models and channel conditions, and we provide channel estimation, robust beamforming, and access point selection. Here, for the benchmark scenario, you see the receive power in an indoor area, while carrier emitter focus power to the backscatter device. And as you can see, interference hitting to the reader. But with the proposed method, we remove the interference at the reader location. And later, backscatter device can send the information to the reader while there is no interference. We also extend this idea to the distributed networks. As you can see, for the distributed setup in the reader locations, there is interference while we focus power to backscatter device. With the proposed method, we optimally select access points and design beamforming coefficients such that interference at the reader locations are removed, while we still focus power to backscatter device. As a result, we can use low-cost hardwares in our access points. In another work, we also propose robust beamforming and access point selection under the channel uncertainty. We didn't stop at this point, and we extend our work by experimentally testing our algorithms. Here, carrier emitters focus power to the backscatter device, and reader receive the reflected signal from backscatter device. For the benchmark scenario, carrier emitters focus power to the backscatter device, and we plot the received power over the white square. And as you can see, in the selected reader location, there is strong interference. With the proposed method, we remove this interference by shaping the transmitted signal while we still focus power to the backscatter device. As a result, we make whispers audible next to jet engines. In conclusion, the proposed methods enable interference management, low-cost hardware usage, robustness against channel estimation. As a result, our solution is a great potential for energy and cost-efficient massive IoT networks. Thank you.